All right, that was a great session to start off our day. Thank you, Dave. And if you're just joining us, a quick reminder that we will take questions at the end of the session. Please submit your questions using the questions tab located at the top of your screen. If we don't get to your question, please know that someone from the Neo4j team will reach out to you directly, or simply send an email to webinar@neo4j.com and we'll get your question routed to the appropriate person. And now here's Lance Walter to introduce our next speaker.
Thanks, Marilee. We've got a great opportunity to double click on this intersection of graphs and machine learning in a government context with Nisha Iyer, Vice President of Data Science and Engineering at Data Society, and Greta Workman from our product marketing team. The world has definitely figured out that graphs can play a key role in machine learning and AI applications, and we're seeing that power some really new, exciting new use cases, and as I mentioned before, adding really cool machine learning superpowers to existing apps. Nisha Iyer has been with Data Society for nearly 4 years. Prior to Data Society, Nisha held data science and management consulting roles at organizations including Discovery Communications and Booz Allen Hamilton. And Nisha holds a bachelor's degree in communications from University of Maryland. Greta Workman works on our product marketing team with a focus on helping our customers showcase their success with Neo4j. She's a 6-year Neo4j veteran, originally starting in our field marketing team. And Greta has a bachelor's degree in economics from Columbia University and a Bachelor of Arts degree in political economy from Barnard College. Well, let's talk graphs and data science for government organizations with Nisha and Greta. Nisha and Greta, welcome to Neo4j Connections.
Thank you so much, Lance, and thanks to all of you for joining us today. I'm really excited about this session. I have with me today Nisha Iyer. She's VP of Data Science and Engineering at Data Society, which is a company that's helped agencies across the government implement innovative graph solutions. Today, we're going to hear about 2 of those implementations and also just kind of talk with Nisha about her experience implementing in the government. So Nisha, do you want to take it away? I'll let you introduce yourself and then also introduce the Air Force demo.
Sure. Thank you so much, Greta. And I'm really excited to be here today and to talk about my and our company, Data Society's experience using Neo4j on a couple of projects. And the first demo I am going to show you today, I just want to say, you know, a couple years ago, I wasn't working with graphs. I was working with relational and non-relational databases. And over the last year, I've really gotten to use graph databases and to understand the power behind them. And I hope that you're able to see them through the demos that I show you today. So the first demo I'm going to show you is something we built for the Air Force, and it was for the Chief Data Officer's office, and it was sponsored by General Van Ovost, who is the only female 4-star general in the Air Force, and actually one of 2 female 4-star generals in the entire Department of Defense. So I will go to the demo, and so what this tool, the problem that was brought to us was there are a lot of people out there that are put on cybersecurity projects that have a very limited knowledge of cybersecurity. And personally, I am not a cybersecurity expert at all. So this was actually helpful for me to come in at the point I did, because the question was, can you build us a semantic search engine? So a search engine that will allow our users to type in a problem that they're having. So let's say a user comes in as a novice and says, I am getting weird emails. So they wanted a tool that the user can type this in and they are able to get a list of attacks that could be occurring on their system or network or whatever they are concerned about. So what you see here is a semantic search engine, which we built ourselves. So that is the AI layer, and it sits on top of Neo4j. So it's backed by Neo4j. And how we use Neo4j is we built a knowledge graph. The reason for this is that the ontology of cybersecurity is vast. It covers so many aspects, so many different data sources, and cybersecurity is data. The way that you understand cybersecurity is by going through logs, by going through user activity, those, so many things like that. And what people are unable to understand is how do I connect all these disparate data sources that usually don't seem connectable with relational databases? They just seem, and it's a lot of unstructured data, so a lot of text. And so what we were able to do with a graph database with Neo4j was to actually build a graph database where each of the objects were things like attacks and products and other cybersecurity related items, and the relationships between the nodes, which is what builds this entire graph, were built through using natural language processing. And so because we're able to connect unstructured pieces of text using similarity, using machine learning, natural language processing, we're able to connect many sources that usually wouldn't seem so similar. So here what has happened is the user says, I am getting weird emails, and they are directed to the most similar attacks that could be occurring based on their query. And as you can see here, this is not a full text search. There is not, I am getting weird emails anywhere in this description. This is based on what the AI understands as what the user is asking. And so let's go into the most similar attack, which is email collection. And once again, so this is going to bring us to the landing page of the information about the attack. And to someone that doesn't know cyber, you may say, okay, this looks like a page that just describes an attack. Cool. But what's actually happening is there are so many pieces of information that usually would take hours to find, all on one page. And I know this because, like I said, when I started this project, I didn't have much background on cyber. So I thought to myself, why are we building a semantic search engine? Why can't we just use Google? Google's a great search engine. And Google's power comes from the speed and the ability to index and the Boolean search and, just so many things that Google's so great at. But what isn't happening is that specific semantic search and connection of so many disparate data sources. And here what is happening is that, as you can see, there's a description, there's quick insights, vulnerabilities that are related to attack, and then there's detection, mitigations, and remediations. And the remediations and vulnerabilities are two areas that cybersecurity experts told us would be impossible to just pull up if based on the attack. So when I did this, when I did the user research for myself, I went through Googling attacks and trying to solve them for myself. And I realized why we needed to build a tool like this. It did take hours to find what I can find in one step. As you saw, all the user has to do is enter a query, and they are brought to a page where all their questions are answered to help them understand how to deal with the attack, what might be happening on their machine, and how to completely eradicate the threat. And this is, once again, the illustration of the power of the graph database, the ability to traverse these multiple disparate data sources and to build relationships using natural language processing between those disparate data sources and give the end user a simple and clear answer. So I'm going to pause there. Greta, do you have any questions?
Yeah, absolutely. What an interesting demo. Thanks so much for that. So how are your end users typically solving these problems before graphs, and why didn't that really work for them?
Yeah, so it's a great question. And this is also, one of the reasons I get so excited to present this to our end users, because they haven't been able to solve a lot of their problems before graphs. They have been stuck in relational database world, thinking that it's impossible to make connections between these, multiple data sources that they have. And in fact, it's not. And so how graphs have helped that is opening their eyes to this new possibility of being able to make so many connections between disparate data sources and to be able to build relationships within a database, not to have to add the machine learning layer on top of the database, but to actually be able to build those connections within the database using machine learning techniques such as natural language processing. So I think that graphs are just opening people's eyes as we show them the strength of what they can do when combined with other aspects of the architecture.
Yeah, totally. Can you talk about their reactions a little bit? How did their workflows change, I guess, in their daily lives?
Yeah, so I think just like as I went over in the Air Force demo, people were searching multiple databases and like trying to understand a problem that they didn't have too much experience with, cyber related, and were taking days, weeks to solve problems because they were so inundated with other work streams as well. And what this tool helps is kind of keep them on this track of being able to just give them the information they need. It's like an information dump and then a semantic search engine on top of it that's able to make sense out of that information dump. And it's able to make sense out of that information dump because of the graph.
Yeah, and I mean, I feel like that use case of like kind of the need to be able to connect disparate data sources is kind of prevalent, across not only across the government, but also across industries as well. What are some other ways that you've seen that kind of taking shape and being used? And maybe also if you want to jump into the other demo that you're going to show.
Yeah, sure. So I just think that, the next demo illustrates that the architecture that we built, the underlying architecture with the graph and using a knowledge graph to combine these disparate data sources, it illustrates that it could be used not only for other industries, but also for totally different use cases. So yeah, exactly. This segues great to our next demo, which is for the Consumer Finance Protection Bureau, CFPB. And instead of semantic search engine that sits on top of a knowledge graph, we actually ended up using an unsupervised machine learning algorithm that sits on top of a knowledge graph, and it provides very similar power. So I am going to go to that demo now. So what this is it was built to help with fair lending practices. And so a consumer, the target user is a consumer. Consumer comes in, has just received an interest rate from an institution, and they want to know, is it fair? Is this what people that look like them objectively are receiving as interest rates? So they just put in some information about their loan. They don't have to enter everything. And by the way, this is all being pulled back into the graph to further fuel the algorithms. So they go to find loans like me. And what they see is they see that their loan is based on the group that they choose. They're in the 71st percentile, this person. So 71% of borrowers are under them, have a percentage, loan percentage, interest percentage under them, and however look like them. And then there is a derived equation that sits on top of the graph database that tells them what their risk of discrimination is. And the purpose of this tool is to raise awareness of fair lending and also to kind of report these things to the CFPB easily. So when the CFPB came to us, they said, we don't have people don't want to report this after they found out, like while they're at the bank, they don't come home. Their initial reaction isn't to come to the CFPB website and report something. So this is a mobile friendly app, and they're able to say report to the CFPB, submit it, and it goes to directly back into the graph. And the way the graph database helps this is that there is so much varying information, both structured and unstructured. The unstructured information fuels us to be able to determine what the risk of discrimination is. And so that means that we're pulling in soft indicators and reputation scores based off of news, on financial institutions in the area, and off of any kind of traffic that's going on with interest rates and mortgages. And also just any social media news that might be of interest to influence this. And that all sits within the graph. And then another thing that is there is the structured information, such as the features that are most important in predicting the interest rate. And that is all listed here. So as you can see, this person has come in and sees that these other loans, these people all look like them subjectively or objectively. However, when they come up to demographics, they see that these loans are all varying interest rates under them. And demographically, they don't look similar to these people. And so therefore, they can kind of make their own assumptions and say, yes, I think, that I do agree that I might be being discriminated against, and report this. And the way that we really saw graphs helping us here is, once again, connecting disparate data sources and being able to find relationships between demographics, loan information, external reputation scores, but also the ability for us to build groups. So the way that we're able to find groups of people that look similar is by using an unsupervised algorithm clustering. To do this at scale, even just at a state level, even though this goes down to county level, we would have to build at least 50 unsupervised clustering models on large amounts of data. And that is very computationally intensive. So as to what I spoke to earlier, this reduces the ability to use the graphs, reduces that computational intensity, because the first layer of similarities between people is happening within the graph. So we're able to see which people are most similar to each other in the actual database. And then on top of that graph database, we put one unsupervised algorithm, which is a lot less computationally intensive, and it's able to give us the same information. So once again, I think that the case for graphs is obvious, and I think that it is the way that databases will be moving towards, because there's so many different ways that the graph database can be used. So I'll stop there, Greta, and please feel free to ask any questions.
Yeah, totally. Thank you so much for that. Okay, so for both of these projects, why would you say you chose a graph? What about a graph structure specifically was needed to solve these problems?
Sure. So when I started researching for the Air Force, so the Air Force was the first time we actually used the entire graph architecture in Neo4j. And I knew that coming into the project that the universe of cyber has such a vast ontology, so many different topics at such a meta level. And it was just it just felt like, jumping into, once again, like a huge information dump, like so many different aspects. And the way to wrangle that in was to build a knowledge graph. So to kind of like divide the information into sections. And we came up with 3 sections: a research layer, a knowledge base layer, and a product and filtering layer. So with those 3 sections, I then looked into what were some techniques to build out knowledge graphs. And I did come across a few demos that showed how to build them with relational databases. And the big difference I saw is, and the reason, hands down, that we went with a graph database in Neo was that with a relational database, a lot of like the intricate information was lost. And with Neo4j, that intricate information was used to find similarities, and those similarities become relationships. So I think that that's what makes that. It's just using all the information that's usually lost with a traditional relational database build.
Yeah, totally. And graph algorithms too was kind of a big part of both of these projects. Can you dive into your use of algos a little bit? Like which algorithms did you use, and what kind of insights did they help you generate?
Yeah, sure. So we used 2 different algorithms. For the semantic search, we built our own semantic search based off of a very popular language model that Google has built, BERT. And that model has actually been trained on large amounts of all different types of text to just understand in general semantically what people are saying. And then our model was specifically trained on cyber. And then also we were able to take in annotations from cyber experts. And the way that the graph really helped us build this out, like the graph algorithm, how it became a graph algorithm and how it helped influence the AI, is that it was able to be pulled into the database easily, and then influence and help the artificial intelligence gain knowledge as more and more people are coming in, annotating and saying, yes, the model has done a good job, or no, it hasn't. And then for the CFPB, we used an unsupervised learning algorithm. And what was so great about that, I talked about it in the demo, but it was just the power of being able to use 1 instead of 50, which made it a lot less computationally intensive.
How did you find was the learning curve for graph algorithms? What resources did you use? Did you find it kind of easy to pick up? Do you have any advice for people getting started?
Yeah, I think my advice would just be to just really jump in there and start taking tutorials and understand and more about the graph, not the algorithm. The algorithms are its own, they kind of, there's a lot of algorithms out there. They can work with graph databases. They could also work with data that's pulled out of relational databases. My advice would be to understand the graph and to understand how you can really, really get the power out of the graph. Because also something I saw when I first started working with Neo was that my team was using it like a relational database. Like there's ways to just like, okay, like this is just traditionally how we would, this is how we would get data into the database. This is what we're going to do. This is what we're going to name the, and we had to take a step back and say, no, we're not using the power of the graph. And if we do use the power of the graph, we're not like, we're able to run algorithms within the database and then also on top. So I think my advice would be go to Neo4j because that's what I did. And I was able to find tutorials on Cypher. I was really just able to get in and see visualizations of graphs being made with code I was writing. And it just helped me get a feel of like what could be done with graphs.
Yeah, totally. I feel like it's definitely kind of a mental switch from the relational world to be able to build graphs. All right, my next question is kind of a big one, but what do you think is kind of the future of graph technology? Where do you see there being an opportunity for governments to leverage graphs more?
Yeah, that's a great question. I really hope that people are able to speak to more people that have had experiences like myself and Data Society, where graphs have really opened up their world and are able to understand that there is so much more to graph data. So we talk to a lot of government clients, and when they hear we're using graph databases, they jump to entity resolution. And I think that, yes, that is a very powerful aspect of graph databases. However, there's so much more. I think that with the right mindset and with the right open mind to understand that this is not going to look like your traditional relational database. However, this could be a lot more powerful when used correctly, could bring graphs to so many projects and could actually help with the community and interconnectedness of the agencies and even within agencies.
Yeah, totally. Do you have any advice for people trying to bring Neo into their government agency or into a government agency?
I would just say to start working on something within with their company and come up with a plan and illustrate why Neo would be powerful. I think if you just say Neo4j is a graph database and we've heard great things and we want to try to use it, that's a lot less powerful than saying like, hey, we could solve this problem for you using Neo4j. That's how we actually the chief data office at the Air Force didn't have Neo as one of their list of providers on their secure infrastructure, and by what we showed them, we were able to get Neo4j licensed on the vault. So I definitely think it's worth explaining and illustrating what a graph could do, and not to give up.
Yeah, that's so interesting. Well, thank you so much for being here today, Nisha. I'm going to pass it back over to Marilee for some audience questions, but this was such a great conversation. So thank you so much.
Yeah, thank you.
Oh, thanks to both of you. That was excellent. We have had some questions from the audience, and I want to remind the audience, if they'd like to submit a question, they can do so by typing it into the questions tab located at the top of your screen. But here's one that came in earlier. I believe was it during your first demo. It's asking, have you seen this semantic search be used to find data sets within a company?
So thank you, Marilee, and thanks for the question. I actually, this is a great question. I've gotten it a couple of times when we have actually demoed the semantic search tool. I have not seen it being done, but I think that we are thinking through an architecture where it could be done. And the challenging part of a semantic search to find data sets would be that we would have to be able to identify millions of data sets. And instead of having, people say this data set does X, Y, and Z, the problem that we have gotten from companies is that they have so many data sets within their company and sitting in different places, and they don't have descriptions, and people don't know what they are, and they're often looking for data and they're not able to find it. So I think that we would have to build a deep learning algorithm that's similar to an image recognition algorithm that would actually be able to classify and label data sets within the company, and then on top of that, the semantic search engine would be able to understand what the user is looking for and spit back the data set that the user needs.
Oh, okay, I get that. So I think this is a follow-on question to that. It's like, what model did you use to build the semantic search engine?
So I think I spoke about this a little earlier, but we used a large pre-trained model, and then we trained it on our own data so that we were able to help the model understand the context of cyber. So for this data set the data set semantic search engine, it would actually be trained on the data sets, and it would be trained on the meta tags for those data sets. So it would be able to say, okay, I see this data set and it looks like all these other data sets. And then it would also be able to make metadata tags for new data sets. So that's kind of how that works.
Excellent, thank you. And here's the one last one before we wrap up for today. So if people wanted to get in contact with you to talk about kind of the process, and you mentioned like getting started with the project and just showing what the power of graph can do, like how would they get in touch with you to learn more or have a conversation with you?
Sure. So they could either reach out to me directly at nisha@datasociety.com. They could also reach out to hello@datasociety.com, which is in general inquiries about what we could do for them, or any other questions about how we've worked with graphs. So thank you so much.
All right, thank you. Thank you so much, Nisha, for being here today. We really appreciate your time. And for those in the audience, stay tuned. Our next session will be starting in just a few minutes. Thanks again.
Thank you.